Okay, this is an introduction to Lesson 5.4, and the topic of Lesson 5.4 is called special parallelograms. And about the last week, we've been talking about parallelograms, and let's just make sure we understand the characteristics of a parallelogram. If you have a parallelogram, remember the opposite sides are equal, so both pairs of opposite sides are equal. If you have a parallelogram, we also know the opposite angles are equal. So that pair are equal to one another. This pair is equal to one another. Something else that a parallelogram has is we know that the diagonals, so if I have one diagonal there and one diagonal there, the diagonals bisect each other. So they cut each other into half. So those two parts are equal and these two parts are equal to one another. We also know that both pairs of opposite sides are parallel to one another. So in other words, this side and this side are parallel, and this pair of sides are parallel. And those are the characteristics of a parallelogram. Now you got to remember, the rest of this podcast, when we're talking about these squares, these rectangles, and all these things, remember, all these are parallelograms. They have these characteristics. All right, so the first part here is, let's just briefly talk about some of these special types of parallelograms. And these are definitions that you have on worksheet 314. So you want to make sure you print off a hard copy of worksheet 314 because it's going to save you a lot of time and a lot of grief here because you'll have all these definitions on that worksheet. So print off a hard copy, stick it in your notebook so you have access to it. Now a rectangle is a quadrilateral, or in other words, a parallelogram that has four right angles. So if you have a parallelogram with four right angles, we call it it's a rectangle. Anything with four right angles that has four sides is a rectangle. Now a rhombus is a four-sided figure, or a parallelogram, or a quadrilateral with four congruent sides. So if you have a four-sided figure, a parallelogram that has four equal sides, it's considered to be a rhombus. A square now has a few of the properties of the two things above. So as I circle the word square, a square is going to have the characteristics of a rhombus, but it's also going to have the characteristics of a rectangle. So a square is a quadrilateral with four equal sides, like a rhombus, but it also has four right angles, like a rectangle. Now, Theorem 512, you'll want to write this in your notebooks. Theorem 512 says the diagonals of a rectangle are congruent. Now, notice that I've been emphasizing that every type of these figures that I'm going to talk about in this podcast are parallelograms. So remember, since this figure right here, A, B, C, D, since it's a parallelogram, we know that the diagonals bisect each other. We know that. But also, since they're telling you it's a rectangle also has another special characteristic, and that is that the diagonals AC, that diagonal is congruent to the other diagonal, BD. If you just have a regular parallelogram, that may not happen. But if you know the parallelogram is a rectangle, this is true, that the two diagonals bisect each other. Okay, in a moment, pause this and copy down Theorem 513. Now in Theorem 513, now how about if you know you have a rhombus? Now if we have a rhombus, remember we said earlier, by definition, a rhombus has four equal sides. That's all a rhombus has to have. Now if you have a rhombus, a special characteristic of this is that the diagonals are perpendicular to one another. Now remember, since this figure right here is also a parallelogram, we know that and I'm going to mark these a little different way here. Since it's a parallelogram, what do we know about the diagonals? Well, they bisect each other, right? So we know that. But also, if you have a rhombus, the diagonals are going to be perpendicular. So in other words, they form right angles if you have a rhombus. All right, pause this and copy down Theorem 514. Now in Theorem 514, it says, if you have a rhombus, so again, if you have a rhombus, each diagonal of a rhombus bisects the two angles of the rhombus. So in other words, if I highlight this diagonal right here, this diagonal is going to bisect this angle into two equal parts. So angle 5 is congruent to angle 6. It's also going to bisect this angle into two equal parts. Angle 7 is congruent to angle 8. This diagonal right here is going to bisect this angle into two parts, equal parts. So angle 1 is congruent to angle 2. And finally, angle 3 is congruent to angle 4. So if you have a rhombus, the diagonals, not only do the diagonals bisect each other, but also they bisect the angles of the rhombus. Remember also this theorem, if you have a rhombus. The diagonals are perpendicular to one another. All right, pause this and write down theorem 515. Now, theorem 515, I put a little star by this one because you're going to use this one quite a bit. If you have a right triangle, so notice that we have a right triangle here. The midpoint, if we know that D is the midpoint of the hypotenuse. Now, remember the hypotenuse is the opposite the right angle. If you know D is the midpoint of the hypotenuse, then this happens then. Okay, this part is equal to this part, which is equal to this part. So in other words, the midpoint is equal distant from the three vertices. So AD, okay, is congruent to CD, and also BD is equal to or congruent to CD, and so on. So in other words, this part is the same distance as this part, which is the same distance as that part. Okay? That's only if D is a midpoint. All right, pause this and write down theorem 516. Now in theorem 516, it says if an angle of a parallelogram. Now here they're just telling you have a parallelogram. If one angle is a right angle, all of them have to be right angles. Now the reason on that is, what do you know about a parallelogram? You know the opposite sides are parallel, right? So these are parallel. Now if this is a transversal, these angles are same side interiors, which means they're supplementary. So if this is 90, this one has to be 90 in order to add up to 180. And virtually you can do that with all the sides so that eventually all these angles are right angles. So in a parallelogram, if one angle is a right angle, they're all right angles. And that comes in helpful in identifying if a figure is a rectangle. Because if it's a rectangle, then we can use some other theorems for it. Okay, theorem 517. Pause this. Now in theorem 517, it says if two consecutive sides of a parallelogram. So here you just have a generic parallelogram. If two sides right after one another, consecutive means right in a row. So it could be that side, or it could be this side and this side, or it could be this side and this side. If two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Why? Well, if this is a parallelogram, what do you know about the opposite sides? They're equal. So if this and this side are equal. So you can kind of see where this theorem comes from.